Spherical shell, no sir, not hemispherical.
Hemispherical. I'll make correction mark. Yeah. Now see this thin uniform hemispherical shell. I'll write it. Uniform.
Sir,
Ah.
sir, in case of solid hemisphere or some solid objects, we can't apply that perpendicular axis theorem, right, sir?
Yes. Yeah.
Yes, sir.
No, you should not apply that. Only for laminar bodies, perpendicular theorem is applicable. Okay, this is about the diagram given. Let's see that how you manage this one. Read the question properly. Thin hemispherical shell. We know for spherical shell how much it is. 2 by 3 mr square. That is enough to solve this problem. And it's a 3D object. You cannot apply perpendicular axis theorem. This is very, very important. So spherical shell, I'll shade it. So let's show that. Yeah. See, what is the problem with our advanced mains paper now? Technology got improved now. They don't want to give these color diagrams also. It's very bad. Still, uh, people are using some 300, 400 years old technology. In mains advanced paper, final exam, when you write, you don't get this color diagram. They are supposed to give. They don't want to change themselves. Huh? That's a major problem with our Indian education system. Nobody likes changes. They just want things as it is. Finish or no changes. We don't like changes in our lifestyle. That is a major problem. What you learnt in school, you want like this in college only. How you learnt in college, like that you want in IITs. That is a major problem with even the student also. The mindset will never. You should always be ready for changes. So of course, changes will help us a lot to learn. Schools, it was taught very slowly, sir. Now you teach. It's a college, no? The changes are there. Accept it. Head off for college conditions as early as possible. Hmm? I'm not scolding you, but that is what a life. Always you should accept the changes as early as possible, and you have to adapt for it. I think it's problem. No need of integration. That much I can help you. What is the int? I'm saying that no need of integration. Without integration, you can solve it. Hope I think diagram with the diagram I'm helping you a lot. Perpendicular axis theorem is ruled out. That much what we have. So this is a B. Let me take it here. So I'll proceed with the now for hemispherical shell. Can we find out moment of inertia? I think first we'll cover up our basic ideas first. I'll get into the problem. First, let's focus on the basic thing. Now I'll put everything in one page. This again. Let's come for this. Let's go back to the shell idea. This is what our diagram. I'm keeping diagram like this. Let's focus on the shell concept here now. What is moment of inertia about about x-axis? You should answer this. This having a radius r, having a mass m. Anybody? Ixxo dash should be equal to how much? 2 by 3 mr square only. But sir, hemispherical shell and shell, I think it's understood. It's a shell. No. Come to this one. You assume a complete spherical shell, half of it. So how much it will be? About any diameter 2 by 3 mr square. You remove one symmetrical part, the mass will become 2 times, moment of inertia will become 2 times. So I'm writing 2 by 3 mr square. We know only this much here. Now what I do is like, I will so this is one more axis. Please do notice the diagram. I'm going for plain diagram so that it'll be easy for me to explain the concept. And this is what our axis about which it has to be determined, IAB. I'll assume another parallel axis, an axis parallel to this one. Can we apply parallaxis theorem?
Yes, sir.
Please don't repeat anything. Just do listen. No need of S, no also. Control your emotions. No, this is A, this is B. So I'll call this is axis passing through O, not center of mass. Not center of mass. I'll call P dash. Let me give name. Then further. But we don't know IP, O, P dash also. You look at this. I'll shade some part. Can I bring this the other part here? This red color part, shall I place it here? The same diagram, everything. This red color part, I'll shift it. Oh. So what I do is, the red color part, can I shift that here? I think nothing difference. Still what happened, the distribution of mass about axis, POP dash, is same, no? Will I agree? So first we'll calculate what is IPOP dash. It's second diagram. Looking at the diagram here, you have to answer me what is IPOP dash. Looking at the diagram, what is the mass M, what is the radius R. So this should be equal to 2 by 3 mr square only. In this diagram also, can you write in that way, sir? So here also, how much IPOP dash is equal to 2 by 3 mr square only. Will I agree? The mass is the red color shaded part is what I just shifted here. It's not a, see, I'm showing plain diagram. It's a part of hemisphere that I'm going to cut and I'm bring it here. So therefore, what you calculate in the first diagram, moment of inertia, the same thing will be there in the second diagram also. And we know this will be much easier. Looking at the third diagram, in the third diagram, it's much easier, no? So that one I just tilted it. So like this and also I'm going to take help of that one here. So now what we know IPOP dash. So we know moment of inertia about IPOP dash. What we needed? We needed IAB. That's what our question. But this O is not center of mass. Now where the center of mass? Center of mass will lie somewhere here. How to calculate center of mass of this? Center of mass for center of mass for this, it will be here, no? Oh, center of mass for this, it will be here. Center of mass for this, where it will be? It will be here, no? So both shall I write C only? No problem. For hemispherical shell, where center of mass will be? R by 2. OC equal to OA. OC should be equal to R by 2. OA is R. OA equal to OB equal to R. And OC equal to R by 2. And what is R? What is C? C the center of mass. Now, can we apply? Do we know IPOP dash? Yes, we know. Then I'll apply parallaxis theorem about center of mass here. Then I'll calculate IAB. This is a method involved here. So I'll go for now about axis passing to center of mass. So one more axis I have to draw. Call this is CC dash. So I C C dash. Oh, so sorry, this one. So this should be equal to high PO P dash. This should be equal to ICC dash plus M into OC square. Do we know IPO dash? Yes, it is. Then from here I'll apply IAB. What is IAB is equal to ICC dash plus M into the distance here I should call P views, no? I'll call D. D it is. So CD whole square. So what is CD again? CD should be equal to, how to calculate CD? We don't know CD, no?
Sir,
Ah.
why can't we find ICC dash in the first figure, sir, instead of in the second one?
Hi, you can find out anywhere, huh? Because compared to diagram 2, I should discuss it's like I just brought here because IPOP dash we have found out. Now you should apply this one. So here, looking at this, I found out ICC dash. But our question is what? Something asking IAB, no? So for IAB, I'll take the diagram 2, then diagram 1 or 3. Also diagram 3. Okay, this is IC dash, I'll call it.
Sir,
Ah,
sir, we can directly find OD, no, sir.
which one?
We can directly find the length of OD and directly get IAB, sir.
Ah, see, but you cannot apply parallaxis theorem from PP dash to AB, no? OD you can find out. OD is what? Because you know AB and AD, you'll get to OD. From OD, what happen? You can calculate that one. I just shown that CD that one. But CD is not needed, no? For that, what happen? What is OC? OC is R by 2. You calculate OD, then subtract. So what is CD? CD will be OD minus OC. OC is R by 2. Calculate OD now. How to calculate OD? So where do D will lie? D will lie here. Come for this. How to calculate OD? From triangle. Is that okay? No. So from this basic triangle. Okay, now in this diagram only I'll indicate. So this is D, no? Okay, now how you can bring OD from here? OD is a perpendicular, so this we know it's a perpendicular. Will OD will be perpendicular bisector for AB? Yes, it should be no from this triangle. You look at the OA, OB is equal to OA. So therefore, and OD is what? Perpendicular bisector of AB. So therefore, AD should be equal to BD. I think a triangle AD should be equal to BD. And we know AB. Half of it what? We'll get that one. So again, I'll go for the triangle OAD. I'll go for it. OA square equal to DA square plus OD square. And we know that AD is equal to DB. And what is AB? AB is R root 2. Anybody check, work out and tell me the answer.
So OD will be R by root 2.
Yes, sir.
OD will be R by root 2. And OC is how much?
Sir, R into root 2 minus 1 by 2.
Yeah, this will be. Okay, this is CD. That you substitute here and solve it. Finally, our question is what? To get AB, no? AB has to determine. Okay, these are the, just check it, some symmetry or all particular thing. These are very important questions, can be asked in advance. I just introduced for hemisphere. Inverse value, IAB.
So 7 minus 3 root 2 by 12 mr by 6 mr square.
Why so much?
Sir, CD will get root 2 minus 1 by 2 R.
R by root 2, no? OD is what? Oh, CD is OD
Sir,
minus
OC is R by 2, sir.
Yes, sir, R
OC is
by
R
2
by
that
2.
is.
Sorry, R by 2 it is. And now one more biggest thing is like for the second diagram we should do, or the first diagram we should do all calculation.
Sir,
Yeah.
sir, what will be the answer?
Answer I don't have. I just made a guess of diagram. Anybody? This angle will be 45. This will be 45. Yes, nobody is there to calculate.
Sir, I got 7 minus 3 root 2 by 6 mr square.
Yes, sir, I got the same.
Same thing. 7 by 6. Others are giving different answer. I'll check in chat. Anybody other answers? Now, book they're given 2 by 3 mr square, 7 by 6 mr square, 5 by 4 mr square, 5 by 3 mr square.
Sir, then it will be 7 mr square by 6.
7 mr square by 6, huh?
Yes, sir. If we apply parallel axis theorem directly, we will get, sir.
Yeah, anything. I'm just suggesting that one.
Sir, then why are we getting different answers, sir?
Sir,
Uh, yeah.
sir, for the second figure, we have applied the parallel axis theorem, right, sir?
Palex theorem, I applied second diagram. Huh? That's what I'm telling this
Yes,
one.
sir, for second diagram. How
Second
can it
diagram.
be the same for the first diagram, sir? It won't be, right?
No, this is the for second diagram about axis AB, that one. But our diagram is what like the first diagram. First diagram is what we are to apply.
Then ICC dash for the first diagram would be different, right, sir, than for the second. I mean,
Distribution
there
of
will be
mass will be
difference,
different, no?
right?
Yeah, they'll be different here. This is what I think. Okay, no.
I think that's where we got it differently, sir. Because for the
Okay, that
second
one.
diagram, we'll get 7 minus root 2 by 6
So what all
mr
this?
square.
Yeah, this one. I'll do one thing. I P O P dash is same. So this will be everything. I'll put for second diagram. Okay, fine. Check your. Yeah, I think this is needed anyway for us. Directly, I think you can apply now Palax's theorem. No? Moment of inertia. Any reason for that? So what you calculate moment of inertia about POP dash. It should be same about high AB also. We'll agree this because of this one. What you calculate moment of inertia about, say from here, what is the conclusion? What we are making is like, what is the moment of inertia about IPOP dash? It will be same about high AB also. Any reason for that? Because of symmetry. This particular thing, when you shift it, the symmetry will come. And we know IPOP dash here. So how to calculate IPOP dash? Is it 2 by 3 mr square? Answer, I'll write it somewhere. 7 by 6, all of you? Now come for this. So directly, first diagram is what we have to look and we have to put the answer here. In the looking at the first diagram is what we have to write it. So what all we did is for the second diagram. The second diagram is what we made IAB, all everything, that one. But the mass is the red color, this particular mass should be present at this particular thing. No? You cannot shift and solve the problem. I just shown the symmetry method. No. What is IPOP? What is IPOP dash? Is it writing like this justified here? Is it writing here justified? Yes, IPOP dash is justified here. So now you apply again here Palax's theorem for this. IC dash, then calculate perpendicular distance, this one. Fine. Then after getting this, then again apply here, you'll get the required answer. Okay, the center of mass will not shift here. For this diagram, it should be here only. For in this diagram is what we have just calculated here. Getting the idea? This one, what you calculate here I think these two diagrams are different. You look at the distribution of mass. This you cannot shift here. Just to calculate IPO P dash is what I just brought the logic. In this one. So now you apply Palax's theorem for this. Then you know this. So calculate that perpendicular distance. So you know this. Then you know that angle 45 degrees. You'll get this about this axis. Then from this axis, then again apply Palax's theorem. Getting all of you? I think in this diagram, so here somebody may ask you, I just brought it, so this, if you are getting confusion, I'll take out this one. This part I'll take it out here. May not help you, because again it will take you to some other way of thinking. And now we know IPOP dash. Now you're going to assume one more axis here and calculate using Palax's theorem. Then after getting that, then about this axis again apply Palax's theorem. How these two are same? Because of symmetry. I think okay, these things, if you are required, okay, you can take help of this one, OD, all that one. Options are given: 2 by 3 mr square, 7 by 6 mr square, 5 by 4 mr square, 5 by 3 mr square. Okay, no. So tomorrow I'll start the talk equal I alpha. Some on Friday I'll discuss some application problems of this kind. Okay, thank you all of you.
Sir, we won't. I'm not getting the answer, sir.
I'll give option check calculations because we have to work out further. I'll update later on because I'm getting time for. I took a
What is the key, sir?
Key not there. Key not there. Key not there. You have to work out. Check once which options are this there. I think C and D are ruled out. Between A and B only it will come. Look at the calculations. Huh?
Wait, option A is what?
2 by 3.
Okay, sir. Thank you.
Between A and B only it will come. C and D are ruled out. Huh? We have to work out. I just had a question. Okay, I'll update later on. When I'm sending the file now, I'll solve it and tell you. Okay, fine, all of you. Thank you very much.